Hello, children. In last discussion, we came to know about resistance, resistivity, and effect of temperature. We also discussed that the types of resistor, that is, two types: wire wound resistor and carbon resistor. Wire wound resistors are made up of wires of an alloy like manganese, constantan, nichrome. The reason they are a small temperature coefficient of resistivity. While we have seen the resistors in the higher range are made from carbon, that is called the carbon resistor. Now today we will discuss electric energy, power and combination of resistors. First, what is electric energy? Have you think think a moment of why a conductors become hot while current passing through it? So today we will try to find the answer of such question. Here, when we on the switch, current starts, and this current flowing from A to B. So obviously, potential at A is greater than potential at B. So potential difference across AB, that is VA minus VB, is greater than 0. In the time interval del t, the amount of charge passes through AB, that is del Q equal to I del T. Once at T equal to 0, the Q charge is at point T. So here the potential energy is Q into V at A. And here when that charge will reach after time T, potential energy will be Q into V at B. So the change in potential energy will be final potential energy minus initial potential energy. So its value will be del Q VB minus VA. Here VA minus VB is greater than 0. So VB minus VA, that is less than 0, negative quantity. So change in potential energy is negative of charge into potential difference, and charge equal to I del T. So change in potential energy will be negative of IV del T. Now if we use the conservation of total energy, that is del K plus del U equal to 0, so del K equal to negative of del U and del U equal to negative of IV del T, so del K equal to IV del T. Now if we consider when the charges are moving freely through the conductor under the action of electric field, their kinetic energy will increase because del K is the positive. But earlier we have seen that charges do not move with acceleration, rather with a steady drift velocity. So what happens to this kinetic energy? During the transmission of charges, the charges collide with ions and atoms. So during that collision, energy gained by the charges, that is shared with atoms, so that atoms starts vibrating, and as a result conductor heats up. So W equal to Q into V, that is VIT. This work done is known as electric energy E. So E equal to VIT. From Ohm's law, V equal to IR, so E equal to I square R. This is the form of energy which is converted into heat energy. Now, electric power. In our class 10, we have learnt that electric power, that is, electric power is rate of doing electric work, or we can say heat energy produced per unit time is electric power. So power equal to E by T, and E, we substitute the value of E as we have learnt just now. We will get P equal to I square R, and again by using Ohm's law we will get its value is VI. SI unit of power is watt and the commercial unit is kilowatt hour. So in our domestic meter, that is called the unit, that is in kilowatt hour. Here in this formula, see P equal to VI. This formula we use the rate of electric energy transfer from a source, and this formula P equal to I square R or V square by R we use to find the rate of transfer of electric energy to heat energy in a resistor of resistance R. Now very simple two questions here. Which of two has higher resistance, a 1000-watt heater or a 100-watt tungsten bulb, both marked for 230 volt? And second, convert 1 kilowatt hour into joule. Next, now the combination of a resistor. Generally, two ways of combination, one is in series and other is in parallel. We will discuss one by one. First, we should know what is the equivalent resistor. A single resistor which draw the same current as the given combination of resistors in series or in parallel when the same potential difference is applied across its endpoints is called equivalent resistor or net resistor. Series combination of resistors. Let here three resistors of resistance R1, R2, R3 are connected by a battery of potential difference V. When I current passes, then I current passes through each resistance. But since resistance of each resistor are differ, so potential difference will differ. Let potential difference across R1, R2, R3 are V1, V2, V3 respectively. So V equal to V1 plus V2 plus V3. If we use the Ohm's law, V1 equal to IR1, V2 equal to IR2 and V3 equal to IR3. So V equal to IR1 plus R2 plus R3. Now if we replace these three resistors by a single resistance, that is RS, then the potential difference V equal to IRS. So if we see the equation 1 and equation 2, we will find the value of Rs equal to R1 plus R2 plus R3. Now here certain points. See this Rs equal to R1 plus R2 plus R3, which is greater than the greatest of all. Whichever so bigger, then equivalent will be more than the biggest one. The voltage across any resistor is directly proportional to the resistance of that resistor. Now, combination of resistors in parallel. Let's here the three resistors R1, R2, R3 are connected in parallel with a battery of potential difference V. Now, at this point current will divide. So let across R1 I1 current, through R2 I2 current, and through R3 I3 current is passing. So here this I is equal to I1 plus I2 plus I3. Again, if we use the Ohm's law across each resistor, we will find I1 equal to V by R1, I2 equal to V by R2, R3 equal I3 equal to V by R3. Because three resistors are in parallel, so potential difference across each is same. So I equal to V by R1 plus V by R2 plus V by R3, or it is V into 1 by R1 plus 1 by R2 plus 1 by R3. If a single resistance which draw the same current as here, let that is Rp, that is the equivalent resistance, then I equal to V by Rp. So again from this equation and this equation, we will find 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now here Rp, which is the equivalent resistance, is the smaller than the smallest of all, and the current in a resistor in a parallel circuit is inversely proportional to the resistance of resistors. Though these two are the main combination, but sometimes in question a mixture of these two